Morning, Eli.
Hi,
How are you this morning?
good. How are you?
Pretty good. Let's see. Since nobody, I tell you what, will you do me a favor? Can you let me know when others come on, and I'll try and walk through the study guide first with you? And then we'll start on a little bit of the homework from 7.1 like we did in class yesterday.
Yes, ma'am. Sounds good.
And then just let me know when somebody else comes on, because I know that I'm going to also cover the guided practice too from the video that was posted today.
Okay, thank you. Sounds good.
Okay. Can you see everything okay?
Yes, ma'am.
Okay. All right. So on the 7.1 study guide, example 1, use the product of powers property. And this is actually kind of multifaceted, but it's really, and this is what I told the kids in class yesterday. This is very, very, very easy. Each thing is really, really easy. The hard part of this concept is when you start layering the different, like each little piece is easy, easy, easy. But then when you start layering them in the bigger problem, that trying to keep them straight is the hard part. But each of the individual rules is not a problem at all. So definitely we'll want to keep these example problems with you while you're working through the homework. But when I say it's easy, what I mean is if you'll just look at A, B, C, and D, when the bases, which that's this number, the 2, or this number, the -3 in this one, -7 in this one, M in this one, when those bases are all the same, in order to multiply this term by this term, you add the exponents. So you just take that 6 and that 8 on the exponent. You confirm the bases are the same. Then you take the 6 and the 8 and you add them together. And that's your final answer. So like with this -3 raised to the 7 power and -3, if there is no exponent, that is actually a 1. And that's something you'll kind of need to remember, is there's a 1 there. So the final answer on that is -3 raised to the 8 power, because you're just adding 7 and 1. On C, there's that understood 1 there. So you add 3, 1, and 4. So your final answer is 8, because 3 plus 1 plus 4 is 8. And on D, the bases are the same. Yes, it's a letter, but the bases are the same. So you add 1, 5, and 6 to get 12. So that's not too bad. Easy, right? Not too bad. The second part of this is, and I know I've got others in, but the second part of this, I'm just kind of recapping this for everybody this morning. The second part of the power property is when you have a power raised to a power. So you've got this base here, 3 to the 3rd, and then all of that raised to the 6th power. You multiply those instead of adding like you did when the bases were like this. You multiply. So it's 3 times 6. Just to review the answers here, we added 3 and 11, so that was 8 to the 14th. This one was 3 plus 6 plus 2, so that was y to the 11th. This one is adding 1 and 3, so this was 6 to the 4th. This one was adding 2, 1, and 5. So that's negative 10 to the 8th. I'm sorry, and now I'm kind of back on this. But so here, once again, just to remind you that we're multiplying. Don't let all the brackets and parentheses scare you guys when you get into these problems. That's just to differentiate that you're keeping that negative 12, and that's really important. And the students yesterday learned that in each of the classes, that how important that is. Because if this negative right here is somewhere else in the problem, it sure does change things. So when they have it inside the parentheses like that, and when you're entering them in your calculator, you want to make sure that you're putting that negative inside the parentheses, but you multiply those together. The other big thing to remember is this right here, this x minus 3. That is a term and needs to be treated as if it were just one number, because later on in Algebra 2, you're going to find out that this right here, this final answer of x minus 3 raised to the 12th power is really a 13-term polynomial. So it's very important that you treat this just like a number, as if it were 12 or just m or something like that. So you just take these exponents and multiply them. And then, so like, I'm just going to do the hardest one out of these, just to remind everybody, keep those together, and that answer is 18. This answer is negative 8 to the 21. All right, and just another reminder on these right here. You want to distribute this 3 to everything inside the parentheses. So that's 6 to the 3rd, like they have written, m to the 3rd, n to the 3rd. Everything inside the parentheses. That exponent gets distributed backwards, if you will. Okay? Now, look at the key difference between C and D. Just reminding everybody, these are good reminders. That negative is on the negative 5. So if I were entering this in my calculator, I would still enter parenthesis, negative 5, close parentheses, raised to the 3rd power. That's very different than this one down here. This one is, what is the opposite of 2 raised to the 4th power times q raised to the 4th power? So 2 to the 4th power is 16. And then I actually apply that negative at the end. I hope everybody sees the difference between these two. All right, I am going to skip ahead and start on some of this 7B. Did anyone have any questions specifically over that?
I have a question on number 27.
Number 27. Okay. 3z question mark to the 3rd power. Okay, well, I know this 3 gets distributed to everything inside the parentheses. So I'm going to have 3 to the 3rd, z still to the question mark, and then what would I have to multiply? Actually, let me do it this way. Three times question mark equals 18. What do I have to multiply 3 by to get to 18?
6.
Yep. So question mark on that one equals 6. Was that your question? Or were you wondering where they got the 27?
No, I was just trying to figure out how you solve for the question mark.
Yeah. Well, it's it's a power to a power, you're multiplying. So what would I have to multiply 3 by to get to 18? Does that make sense?
Yes.
Cool. All right. Any other questions on 7B?
Miss Sparks, can you do number 24?
Number 24. Absolutely, I can. 24. 4p squared times 3p to the 5th, all raised to the 2nd power. So nothing happens with that 4p squared. So I'm just going to continue to bring it down. But this 2, this power of 2, gets applied to everything inside the parentheses. So now I have 3 squared. And then this is a power to a power. So I'm going to multiply 5 times 2. So that gives me 10. And now I'm going to go ahead and get my 3 squared. That's 9. And now I multiply 4 times 9. That's 36 because I'm just going to multiply those regular. And then I'm going to add 2 and 10. So that's my final answer. Hold on just a second. Okay. Sorry about that, guys. All right. So does that make sense to everybody on how that works?
I don't understand how you got p to the 10th. Like, where did that?
Oh, I'm sorry. It's p to the 12th. I wrote it down too quickly. I'm very sorry, guys.
Okay.
You have to add the p and the 10 and the 2. I'm very, very sorry. I had an emergency phone call and I spaced, and I'm really sorry. Everything's good though. Praise God. I just spaced on y'all. My apologies. It's p to the 12th. I do know how to add, I promise.
Can you do 18?
Absolutely. I'm going to go ahead and erase this one. Is that okay? Nobody needs it. I'm trying to use this space so we stay on this same page. Okay, number 18. Number 18 is like the one on the study guide, where that term, this is all one thing, okay? So you treat b plus 1 as if it were just a number. So you multiply 2 times 3. So my final answer is b plus 1 to the 6th. Don't let all the brackets and stuff scare you. It's just a way of trying to keep things neater. Like, just think of them as file folders. This is this little file folder right here is b plus 1 all raised to the second, and then it's put inside another file folder, and that's raised to the third. And to kind of combine those things, you multiply 2 times 3. It's just to try and keep things neat. And like number 19 and number 20, how we did that one in class, this is letting you know that the negative is inside the file folder. This is letting you know that it's outside the file folder and gets applied last. So on this one, this is negative 3 raised to the 4th power. And negative 3 raised to the 4th power is 81. And x raised to the 4th power is x to the 4th. This is 3x raised to the 4th power, so 3 to the 4th times x to the 4th. And then at the very end, you'll apply the negative. So that's going to be 81x to the 4th, and then that's a minus. So you apply the negative at the end, and on number 19, you apply it when you're doing the powers. Any more questions on that one?
On 15, do you just add the exponents?
Yes, sir. Good question. You sure do. So your final answer would be a to the 18th.
Miss Sparks, I have a question.
Yes.
So on the math video that we watched and when it assigned the math problems, I did them, but are we turning them in?
No, I wanted you all to try them, and I am going to go over some of them because I got an email from somebody who could not attend math lab today, and they asked if I would go over some of them. So that is one of the things I plan on doing. I just want to make sure that I have clarified all of the questions with regard to 7.1 before I start into 7.2.
Okay. Thank you.
It's just, I like to assign a few of the problems for you all to at least try before we get to class. Are there any more questions on this? What did y'all get for number 9?
I got negative 4 to the 45th power.
Good job. That's it. So she said she got negative 4 to the 45th power. And you could write it like this, or you could just write it like this. But if you were typing it in your calculator because you really wanted an answer, you better type it in like this. What did y'all get for number 10?
$13 to the 4th times 19 to the 4th.
Good job. So you applied that power of 4 to everything inside the parentheses, correct?
Yes.
Good job.
Would you keep it like that, or could you multiply?
I would just keep it like that.
Okay.
I mean, because if you did 13 to the 4th times 19 to the 4th, you're getting in those big numbers. And remember, I said one of the reasons that we do exponents is to kind of shy away from the bigger numbers. And this, this kind of helps with that, instead of writing a number like 2,947,872,654. Instead of writing that number, you can write things like this. Does that make sense? It just keeps things a little neater when you're working with really ginormous numbers. What did y'all get for number 22?
64x to the 18th power times y to the 6th.
Good job. Everybody understand where she gets that? Okay. Any more questions on this? What did y'all think of this concept overall? Not too bad, right? Just when you start layering things, it can get a little confusing.
I like it.
Yeah. You like it better than systems of equations?
Yes.
All right. I had somebody specifically ask me to do number 4, but I can do all of them if you would like.
Miss Sparks, do we have to do the whole sheet on 7.1?
1 through 27. Hold on just 1 second. I'm going to see if I can screen share something with y'all. Okay. 6. I'm going to do number 1. 6 to the 11th over 6 to the 5th. Just like with multiplication, like with multiplication, you add. With division, you subtract. So you got 11 minus 5. So your final answer, as long as it's positive, goes in the numerator. So it's going to be 6 to the 6th power. Does that make sense? Now on number 2, negative 4th to the 9th power, negative 4th to the 2nd power. I do the subtracting and I get negative 4 to the 7th, 9 minus 2. On number 3, I need to add first. So I'm going to have 9. I've got 9 to the 4th times 9 to the 3rd. Those two are being multiplied in the numerator, so I want to do that first. And so I'm going to get 9 to the 7th over 9 to the 2nd. And then I'll subtract the 7 and the 2. So that's going to give me 9 to the 5th. Okay? So on number 4, this is really like saying 1 times y to the 8th over 1, right? Because any big number is itself over 1. So I would multiply straight across. I'm going to get y to the 8th over y to the 5th. And then 8 minus 5 equals y to the third. Does that make sense to you guys?
Can you scroll down for number 4?
Yes. I think I can. Is that better?
Yes. Can you resolve number 4? I don't fully understand it.
Yes. Okay. When you have something like this, like the y over 8, y to the 8th power, I mean, a big number like that, if I said you need to state that as a fraction, it would be over 1, right? Any number like the number 4. If I need it stated as a fraction, I just put it over 1, right? Does that make sense to you?
Yes.
Okay. So this really is y to the 8th over 1. Correct?
Yes.
So with fractions, you multiply straight across. So I have 1 times y to the 8th. What's 1 times anything? Is itself.
Number.
Right. So that's going to be y to the 8th. And at the bottom, I have y to the 5th times 1. So that's y to the 5th. Correct?
Oh. And then you would just subtract.
And then 8 minus 5, yes, is y to the 3rd.
Okay. Thank you.
No problem. Thank you. Thank you for asking the question. I'm sure you weren't the only one. Any other questions about this one? There were more, right?
Yes, ma'am.
Okay. And like I say, none of these properties all to themselves are very hard. It's just when you start layering them, they can, where? Oh, there they are. They're at the top of the next page. I'm sorry. Okay. So when you have, and so pay really close attention to this, and let's take it one step at a time. When you have a fraction, or remember that a fraction is just a division problem, when you have a division problem, you want to make sure, and it's all raised to a power, you want to make sure that you're applying this exponent to everything inside the parentheses, just like we did with multiplication. So on number 5, that's going to be a squared over b squared. Okay? And you can't do anything after that. So that's literally your final answer for number 5. Once again, on number 6, apply everything to the inside of the parentheses. So that's going to be over y to the third. And then that, remember I did say this in class, like when your numbers 1, 2, 3, 4, 5, and 6, go ahead and get these all the way out. So your final answer for this would look like negative 125 over y to the third for that one.
So you do want us to solve that part?
Yeah, when it's like 2, 3, 4, 5, yeah, go ahead and get those all the way out. Just because I want you guys to get used to some of the lower power numbers. Like when it's 2, you can take 2 all the way up to, we'll take 2 all the way up to 7 or 8, 2 to the 8th power, because I think that's only 256. I think that's 64 and 64. Yeah, that's 128. Or 64 times 2. 132. Yeah. Yeah, take 2 pretty far up, take 3 to about 5 or 6. But like if it's something wacky like 13 to the 7th, don't do that. You know, like if it comes back in your calculator and it doesn't fit on your calculator and gives you something, calculators will look like this: 10e to the 50th. If you get something like that in your calculator, don't worry about it. You know, but if you ended it and gave me this on a test, I'm not going to count that wrong. But I like the fact that y'all are getting used to squares and cubes. If it's, if it's a cube, you really need to know your cubes. Thank you. On number 7, we're starting to stack some of the things that we know. So on number 7, we have in the numerator a power to the power, and that's from 7.1. So you're going to multiply that. You're distributing the 2 on the outside to everything on the inside. Oops, I colored right over it. To everything on the inside. All right. So you want, I'm going to multiply that. That's going to be x to the 4th. And then I'm going to apply that 2 to everything in the denominator. So that's going to be 4 squared y squared. So when I apply the 2 to the numerator, I've got to multiply this 2 and this 2. So that gave me x to the 4th. And when I'm applying the 2 on the outside of the parentheses to everything in the denominator, that's going to be 4 squared y squared. So then my final answer is x to the 4th over 16y squared. Any questions about that?
No, ma'am.
All right, on number 8, a lot going on here. Okay, so for this first one, you're going to apply that 3 to everything in the numerator and everything in the denominator. So I'm going to have 2 cubed s cubed all over 3 cubed t cubed times t to the 5th over 16. 2 cubed is 8 s cubed. 3 cubed is 27 t to the 3rd. And I'm going to go ahead over here and multiply my t to the 5th times 16. All right. So now I'm going to go ahead and bring my this 16 to the front, just so that you can see that you would multiply those on the bottom. Kind of line up my coefficients.
Miss Sparks, can you scroll down a little bit, please?
I don't know that it'll let me. So let me start over here. I'm going to rewrite that last step, okay?
Thank you.
That's all I'm doing, where you can see it better. That's all I did. I literally didn't do any of the math part. I just rewrote it. Okay, sweetie? Now, you can reduce this 8 and 16. Okay, so now, and the s to the 3rd is going to stay at the top. I have 2 times 27 at the bottom, and that's going to give me 54. I have t to the 5th and t to the 3rd, so I want to combine those to make one term. So I'm going to do 5 minus 3, so that's t squared. And this is my final answer. Like I say, each of these individual steps, nothing is really all of that confusing. It's just when you start layering them on top of each other, like you see on number 7, we had to take from 7.1 the part where you're multiplying a power to a power. So you had the 2 times the 2 for the numerator, where you got x to the 4th. And then you have the power, you got 4 squared, y squared, where you're applying that power to everything inside the parentheses. So it's a matter of just remembering all of the rules together. Any questions?
No, ma'am.
Okay. How does everybody feel about this? Clear as mud? I hope we'll practice it a little bit more.
Can you
Are
do
there
some of the problems on 7.1, please?
Absolutely I can. I absolutely can.
Thank you, Miss Sparks.
You're welcome. Have a lovely day.
You too.
Do you just kind of want to confirm that you've got some of them right and me run through at the top?
Yes, please.
Okay. So the answer to the first one, all you're doing is adding straight across. So 4 plus 8 is 12. So it's 5 to the 12th. This one, adding straight across, is negative 4 to the 10th. Number 3, adding straight across, 10 to the 7th. Hold on, just 1 second. Number 4, adding straight across, 2 plus 4 plus 1 is 8 to the 7th. Are you seeing where I'm getting all of these?
Yes, ma'am.
Okay, and don't forget, when there is no exponent, it's an assumed 1. So number 5 is 2 to the 10th. On number 6, because it's a power raised to a power, you've got 3 to the 10th. Number 7, power raised to a power, 9 to the 21st. Number 8, power raised to a power, 15 to the 8th. And we talked about this one earlier. And I would, honestly, anybody who's still with me on Math Lab, I would really go ahead and keep those in parentheses, to be honest with you, just to remind yourselves that you all really need to make sure that you're putting that in your calculators the right way. And then this one, you distribute that 4 to everything inside the parentheses. That's your final answer. You distribute that 6 to everything inside the parentheses. And the primary reason for this exercise is to always remind you that you're doing that even if it's letters or numbers or whatever. Okay? You're distributing the power that's on the outside of the parentheses to everything inside the parentheses. So even though now we're starting with some letters, you still are adding straight across. So it's x to the 7th. Even though these are letters and not numbers, this is going to be x to the 8th, because remember there's a 1 on that. If there's no coefficient, if there's no exponent, it's an understood 1. This is going to be a to the 18th. This is going to be z to the 25th. This is going to be b to the 14th. Oops. Is this making sense?
Yes, ma'am.
Cool. This is going to be b plus 1. That is a term. It cannot be separated. It has to stay together. So that's going to be b plus 1 to the 6th. That's not b to the 6th, 1 to the 6th. It is b plus 1 to the 6th. It has to stay together. I cannot emphasize that enough. It has to stay together. On number 19, that is negative 3 to the 4th, x to the 4th, which then is 81 x to the 4th. And whenever this number here is even if the exponent is, or even if the base is negative, if the power is even, your answer will be positive. If the power is odd, your answer will be negative. Because if this, in simplest of terms, a positive and a negative make a negative, and a negative and a negative make a positive. So if you did that an even number of times, it's going to turn out to be positive. If you do it an odd number of times, it's going to be negative. Number 20, you apply, because the negative is on the outside of the parentheses, you apply it last. So you would have 3 to the 4th, x to the 4th, with the negative on the outside. Then you have the that equals negative 81x to the 4th for the final answer of 81x to the 4th. What do you work with me here? What do you have for 21? What am I going to do?
I got AB to the 10th.
Okay. What you want to do on this one is apply that to everything. You want to apply this 5 to everything inside the parentheses. So that's going to be 2 to the 5th, A to the 5th, and B to the 5th. And then this is its own number itself. You don't multiply that in with the A and the B. So your final answer would be, let's see, 2 to the 5th is 32, because you're raising 2 to the 5th power. Does that make sense or not really?
Kind of.
Okay. This 5 on the outside of the parenthesis is a power. It's an exponent. And it's going to get applied to everything inside. And inside this parenthesis is really the problem, even though it doesn't have this in the middle. That's really what this is. 2 times A times B. But when it's letters, they don't ever write the multiplication, the dot in the middle. So all of that is raised to the 5th power. So then each one of those individual terms gets that 5th power. And 2 to the 5th power, if you plug that in your calculator and you do 2 caret 5, that's 32. Did that make better sense?
Yes, ma'am.
A little?
Yes, ma'am.
Okay. Did 13 and 14 make sense? Or did I go too quickly through those?
13 and 14 made sense, like perfect sense. Those are easy.
Oh, okay, good. How about 15 and 16?
15 made sense. 16 I kind of got.
Okay.
Or never mind. 16 I got. That's pretty easy.
16 you got, so that you understand when there's a power to a power, you multiply instead of add.
Yes, ma'am.
Okay, so 17 you were good with also.
Yes, ma'am.
It was 19, maybe 18 and 19 where it started getting a little squirrely? Or how did you feel about 18? With the fact that b plus 1 is actually one term? Because sometimes that can be a little confusing to some students. And yesterday in class, and I don't know if it was your class or not. I think it might have been another class. The clarification is when there's b plus 1 as opposed to like number 21 where it's 2 times a times b inside the parentheses. This is addition. And these things right here, that's multiplication. That's multiplication going on. That's really saying 2 times a times b. That's 3 terms in there all being multiplied together. This is 2 terms being added. And there's a difference. So you're going to multiply those two. So this is b plus 1 squared. And then that is being raised to the third power, which ultimately gives you the b plus 1 to the sixth. Is it about right here is where that started getting a little more difficult? So I'll slow down. Did you get number 18? Okay.
Yes, ma'am.
Okay, cool. All right, so number 19, that's really inside the parentheses. That's negative 3 times x. And once again, this is being multiplied, not added. And then that's all raised to the fourth power. So when things inside the parentheses are being multiplied, you want to apply this 4 to everything inside. So as long as this is being multiplied, so that's going to be negative 3 raised to the fourth power and x raised to the fourth power. So negative 3 raised to the fourth power, if you plug that in your calculator and you literally type parenthesis, negative 3, close parentheses, caret 4, you would get 81. So the answer is 81x to the fourth. He was snoring in math lab. I'm talking about my dog. Okay, what one was that? Okay, so that was 19. And number 20, so this is the part you're going to apply at the last. So this is 3 to the fourth, x to the fourth, because you're applying this 4 to everything inside the parentheses. So 3 to the fourth is 81, x to the fourth, and then you apply the negative last. because it's outside the parentheses. So there's a difference. So everybody yesterday in class was like, Miss Sparks, they would be the same answer, because what happens if you plug in your calculator -3 to the 4th, just like that, you would get -81. But if you plug in -3 and use those parentheses, you get a +81. That's why you guys really have to be careful. And we did a lot of this in class yesterday to really show the difference of how big those parentheses make. How big a difference. So that was 19 and 20. I'm sorry I kind of barreled through some of these, not realizing that I was going too fast.
You're fine.
All right. Just always holler at me and tell me to slow down. Okay. All right. So now let's go back over 21. So you would apply that 5 to everything inside the parenthesis, right? Is that making more sense now?
Yes, ma'am.
So that's going to be a to the 5th, b to the 5th. And 2 to the 5th, what did we say that was? 32. A to the 5th, b to the 5th. All right. So let's look at number 22. Let's write out the first step. The first step is applying this 6 to everything inside the parentheses. And everything inside the parentheses is being multiplied. Okay? So the 2 is raised to what power?
The 5th.
This right here on number 22. I'm applying this right here to everything inside. So what's it raised to?
The 3rd. Or is it the 6th?
The 6th. Good job. It's the 6th. Because there's an understood 1 on the 2. And when it's a power to a power, you multiply. So 1 times 6 is 6. So what would the x be? Power to a power, you multiply. Three times 6.
18.
Good. And then the y, there's an understood 1. So it will be y to the what? 1 times 6.
6.
Yeah. Does that make sense?
Yes, ma'am.
Okay, cool.
Could you do 23 and 27, please, after this?
Yeah. So that's going to be 64, 18, y to the 6. Which one? 23 and 24?
23 and 27, please.
Oh, 23 and 27. Yes. Did you get 24 earlier?
Yes, ma'am.
Okay. And all right, and number 23. So number 23, you're going to apply this 4 to everything in the parentheses. So the 3 is going to be raised to what power now?
The 4th.
Good job. And the m is going to be raised to what power? It's a power to a power, so you multiply.
4th.
Times 7.
30.
28. And then the final step, if you were going to say 31, that's in the final step because you will combine those in the final step. But 3 to the 4th is 81. And now you will add the m to the 28th and m to the 3rd. So that's going to be m to the 31. But you multiply this 7 and this 4 when it's a power raised to a power. It's just like number 16, except you've got more things inside the parentheses. So you have to do it to everything inside the parentheses. You have to apply the 4 to the 3 and the 4 to the m to the 7th. So the first step is going to be 3 to the 4th, m to the 28. And then I'm just going to bring this one over, that m to the 3rd. That's m to the 3rd. And then the final step is I'm going to find out what 3 to the 4th is. I can type it in my calculator and do 3 caret 4, which gives me 81. And then I'm going to add the exponents on the m because that they have to share the same base. So 28 plus 3. So that's m to the 31. What'd you get for 25?
Question mark equals 2.
On this one, you're adding because it's being multiplied. So this one is 6. See, just like way back up here, we added these. And it's, or this one, we added x to the 7th. When it's being multiplied, you add. When it's a power to a power, so the question mark on 26, what'd you get for that one? Power to a power, you're multiplying. So what did you get for that one?
3.
Yes, good job. And then on number 27, you know that that 3 is distributed to everything inside the parentheses. So we have 3 to the 3rd times z. So question mark times 3 should equal 18. So what would the question mark equal? What do I have to multiply 3 by to get 18?
6.
Yep, so that's what it equals. Does that make sense? Is it getting a little clearer?
Yes, ma'am.
All right, so did you get everything done?
Yes, ma'am.
Praise the Lord. Do you have any more questions for me?
No, ma'am.
All right.
Thank you.
You're welcome. Have a blessed day.
You too. Bye.
Bye-bye.